Yes.
Okay, let's go ahead and move to the next one. Here's another graph. What do you notice? To be fair, we're plotting exactly the same data. Like the data aren't changing between the plots. We're just changing some of the visual appearance of the plot. So what do you notice about this appearance compared to the previous one? All right, let's move to the final one. Here's one final take on same data, different plot. Okay, so let's go back to the first plot and maybe we'll share out. What did you notice about this plot? What were some things that you maybe didn't like about this plot? Yeah. Okay, yeah. No units. What were we gonna say?
I didn't really know if that speaks to color.
Okay. It's right there though. Like that's a really hard place to see because you're already looking here, but it's way down there. So yeah. The information was there, but it wasn't like the computer screen is there blocking you. But like it also maybe it's not the great position for it. What else did we notice? Anything else? Okay.
Or like all of the text is all pretty.
Yeah, pretty small font size. Okay.
Never said it's penguins, so. Yeah, I don't know, I was just like, what bird is this?
Okay. Like so like essentially like what is the context? Yeah, like these are length and depth of like bills, but like what kind of bird? Yeah. Okay, so when we move to the next one, what did you notice for this one?
Oh.
Go ahead.
Okay.
What about this one?
It was easier to kind of draw conclusions based on like the species, just because it doesn't have to do anything.
Okay. Okay. No grid is easier possibly to read.
Yeah.
Yeah. Others?
No title. I think.
Yeah, there's not a title, but we have moved that legend that's way far down there all the way up to the top now. So there's no title. But the color's in a different position, which maybe makes it easier to read, especially if you have a computer monitor blocking your view of sight. Okay. What about the last one? Let's look at the a final one. What do we got? What do we notice here? Well, the length would be here.
Oh, it's the computer.
Computers, I know. Yeah, so we do have length down here, but notice the y-axis no longer has a label. The label is sort of baked into that plot title. What were you gonna say?
I feel like a legend location for here is the best one.
Okay, different legend locations. So now we've seen bottom, top, and now we see side. So this is kind of similar to the one that we had before, where you felt like it was easier to draw conclusions. How do you feel now with this plot? I know I'm putting you on the spot, but now how do you feel about this plot now that it has grid lines added in? It's sort of a step back from the first one where you had both major and minor grid lines, and now you just have major grid lines compared to no grid lines. How do you feel about that?
I feel like this one, the look is very clean,
Mhm.
which is what I like about the previous
Mhm.
one. But this one incorporates the grids, which is important.
Yeah, still has that clean, so like you don't have all of the clutter of the major and minor. But does have that sort of cleaner layout to it, and it does have that like axes. Okay, so these three plots have a lot of things in them that we're gonna talk about in terms of sort of best practices. I don't necessarily think that we have to call them best practices, but like some of these are, I would say, good enough, like that you want to think about even very simple things like the font size and things like that as you're making your plots, but even like the location of your legend and things like that. So let's go ahead and take it away. Go for it.
Okay, so the first one is titles and axes. So let's start off with differentiating what all of these things on a graph could be. So this would be our axis title. So this is like the x-axis. If you were to have one on the y, that would go there, but we're gonna talk a little bit more about that later. And then axis texts are just the things like underneath the tick marks, which are indicated right here. And then the axis line this is the x-axis, that's the y-axis line. So, yep.
Yeah, so those are like the elements of what you can think of like for your text and like putting it sort of incrementally through. Like Lana said, we will talk a little bit more about sort of fonts and things like that, but something that is good to think about is when we're thinking especially about like the font size, that it makes sense to sort of have this hierarchy to your fonts, that like you don't necessarily want your axis title and your axis text to be the same because you want to sort of be able to differentiate, but you still want them both to be readable. So, but making them both large enough to be readable, but also have sort of a contrast between like, this is clearly a title and this is maybe like a subheader or something kind of like that. So the next thing to think about is like, well, what about your plot title? Like the title of your entire plot. Let's go to the next one. Okay, so when you have a title for your plot, hopefully this is a little bit noticeable. So the first thing I want to talk about is not as like what you can use your title for. The middle plot, if we think back to it, like what we did with the plot title was that like the plot title really just reiterated the same two things that were already on the plot. Like to me, a plot title should give your reader new information, or like so give you new information and or like make your plot easier to read. So what we're doing here is we're taking the y-axis label and moving it from here up into the plot title. And you might say, well, why would you want to do that? Well, the reason that from the video that I'm really pulling from is this person said, when somebody's looking at your plot, you don't want to make them tilt their head. So if like, when you think about a y-axis label, it's usually right here and somebody has to sort of tilt their head to read your y-axis label. And so what I've done here is we've moved our y-axis label up here into our plot title. I have kept like the x-axis because that is sort of straight across the board. Like we don't have to tilt our head to read that. So we just keep that. And so then you can say, okay, well, bill length versus bill depth. Bill length is down here. So bill depth should be here. But then it also gives, like, in this title, it gives you that information that you were talking about, like what bird like are we talking about? So now we know that it's penguins. And you can think of it as like, I'm not summarizing the same information. I'm saying, oh, these are built profiles. Like it's the relationship between depth and length and things like that. And then I even have more context for the penguins that says from the Palmer Archipelago, so people know sort of geographically where these penguins are coming from. So like that is what I think of when you make a plot title, is to give more information to your readers. When you think about your plot title, technically, like I feel like so many of us are really drawn to this option, that we're like, we want our title to be centered. And I don't know what in us, like how we got taught that. Like I have those inclinations too. But if you talk to people and you read about like how human eyes perceive things, that it actually is way more clear for your plot title to be left aligned. So even though like you really maybe want to desperately center your plot title, technically that's not the best way, and it doesn't make your plot it actually makes it less clear for people. And so when I say it should be left aligned, notice that the alignment is like kind of even further, that it's not just aligned with where this sort of axis is, like with that line, that it's actually all the way to the edge of my plot. Which maybe is like another step forward, but just thinking about like making your titles left aligned instead of centered is actually more clear. Cool.
Yep.
All right.
I think you covered everything. Right.
We already started.
And then another thing is like what Dr. Theobald was saying, don't make people tilt their head. So
here's a good example, like another way that you can think of that sort of tilting your head. So here I'm plotting, this is technically not penguins, these are rodents. But they have these really long, like genera, like different genus names. So if I were to keep them sort of like horizontal, the names would get all sort of overlapped with each other. And so what I've done is I took those and I just like rotated them. But what do you notice? Like, people have to rotate their head a little bit to read these. And so what is advocated instead is like, there's no reason why I can't just take my plot and rotate my plot. And so now that I've rotated my plot, like I have all of these stacked and they're super easy to read, as opposed to somebody having to tilt their head when they're down here on my x-axis. So there's no reason why your bars, like your names of your bars, can't be on your y-axis and the counts can be on your x-axis. No reason why you can't do that. That helps people not have to tilt their heads. You'll also notice that the bars are in descending order instead of sort of like hopping around. That just makes it easier for people to make comparisons, like Lana will talk about here in a second. Yeah.
I don't know if there's like a rule for this as well, but I feel like the left one is easier to see the bars and like how much the like discrepancy or like how much of a margin there is for the rightmost one compared to everything else. Whereas if it were rotating and then flip on the right side, it's a little bit harder.
Okay, I think that maybe that is, yes, I get what you're saying. That for some people, like when I teach, if you were to have like box plots, like stacked side by side, some people like them to be stacked vertically. And some people like them to be stacked horizontally. And it's sort of a personal preference thing. So just like, to me, like I might be perfect, like these might be exchangeable. Like I can make sort of similar comparisons that like some of them might be a little bit harder. It does make your axis a little bit easier to read, but you could sort of compensate, like Alana's going to talk about, for maybe that being a little bit harder to see sort of the scale of like how different these are, by adding, like taking away this legend or these grid lines and actually just putting numbers here. That way, like people know the exact numbers and they can be like, oh, this number up here is like 14,000 and this one down here is 100. And that way they actually know the solid number of that, as opposed to trying to figure out what that scale is. Yeah, so that's a good reflection. Feel free to like interject any questions that you have as we're going. Okay.
So typography. Fonts do matter.
This is one of my favorite pictures from the person's presentation. It's like very bad.
So something we want to talk about is serif fonts have like the little tails, as you can see highlighted right here, and then sans serif doesn't have like the little tails. So that's just a distinction between the two, and then we're going to talk a little bit more about or I guess I can just talk about it here. But so sans serif is a lot like easier to read, right? Especially numbers. So we want to try to use sans serif fonts as much as we can in our like visualizations. I know serif fonts are typically used for like newspapers and such, where things have a more like, I guess, formal feel, but for sans serif, I guess it's a lot easier on the reader to kind of digest like what you're trying to convey. Anything else to add?
Yeah, it's actually like, it was really fun that it happened while I was teaching sort of data visualization in one of my classes, that the State Department, which is like a federal like organization, so they actually changed their font from Times New Roman to Calibri. And so Times New Roman is a serif font with like the little tails to it. And they changed to Calibri, which is a sans serif font, and they essentially cited that it was for accessibility. And I'm not saying that like Times New Roman isn't accessible, like I think screen readers still can read it, but it's just a little bit harder for people because there's like all of these embellishments going on. So it's actually kind of cool to see like it was also very funny just like to read it in the New York Times, who's using a serif font to write about the conversion to sans serif fonts. But it's like, it was interesting to see people that are actually like a large group, like a large body of things that are coming out of the State Department are actually moving from one font to another because they think it is more clear for people to read.
And then here are some examples of sans serif fonts that you can use.
I really like Roboto. It's one of my favorites. Yeah, they're pretty good.
And then here's another thing. If you do decide to use, I guess like a mixture of both, you want to make like the serif font as like the title, like let's say you have like a big exclamation of what you want to say. And then you want to have the easier thing to read sans serif fonts as opposed to the other way around. It just doesn't look as clean. Yeah. Anything else to add on this slide? Okay. So next we're going to move on to legends and data tables. So here is two examples of different legends. And on the left side, we can see that it's going from like the lowest values to the highest values. And then on the right side, we see the highest values to the lowest values. And what you want to do is you want to make it go from like lowest to highest. And then you also want to keep in mind, because I guess like typically the mind associates like lower numbers with lighter colors. So you want to keep it consistent. So as you can see, the lowest values has the lightest color, and then the highest values has the darkest. Or that's wait. Oh yeah. So that's correct, but you want to make sure that we keep it like consistent.
Yeah, but your gradient here is going from like light to dark, which like just doesn't it's a little bit more clear when you say the darkest colors go with these largest numbers, and then we're going dark to light as opposed to light to dark. Just makes a little bit more sense for people's eyes and just the way that they interpret things. But it does, like, typically people associate like I have a hard time reading plots when the lightest colors are the largest numbers and the darkest colors are the smallest numbers, like, because that just feels like a contradiction in my mind. So just making sure that, like, trying as best you can to have your lighter colors be smaller things and your darker colors be larger things. Did you want to go? Yeah, you're right.
Oh, I already hold on.
Yeah, sorry about that. Here's another example of legends. So here is an example of legend on the right side. But what if we just don't even have the legend and we stick the the values onto next to the bar itself? So this way we don't have to look back and forth. Oh, blue, dark blue is deli, orange is package. Like when you're flipping through, I guess different like let's say you're going between different visualizations or you're reading something and then you look at the visualizations, it can be really hard to go back and forth and remember, oh, orange is packaged. But I feel like on this visualization, you can clearly say, oh, packaged corresponds to this orange one.
Yeah, it's one of those things where you can think about like, if possible, I mean, legends kind of suck. Because like they make people have to go between different places. And so if you can, like Lana was saying, like if you can eliminate your legend, then it makes your plot way more clear. But like let's say like worst case scenario, you're like, I'm not quite sure how to get rid of my legend and get these annotations on my plot. That's fine. Like you can still make your legend more clear. So like we were talking about with like the different positions, like some positions are way more clear. Like I don't think the bottom position, especially when you don't even have a computer monitor, like that it's bound up there in your x-axis label. Like you have two pieces of information there all at the same place. So that's not great. Sometimes the plot title, I'd say sometimes it works like when your legend is up there, but if you also have a plot title, well, then now you have two things there. So I would say usually the side is the most clear, but even if you can move the side, like what we had before was the side was over here. Notice how that has now been sort of like moved into the plot. So now it's like not as far for people to have to sort of compare, but that's like, so that's another way that you can do it. And the final way is like to change this ordering so that like, if I look at the ordering of my legend, that deli comes first, and then this blue one right here would come second, but it's way down here. So I would want it to be deli and then meat, and then packaged, which would be here, and then this one produce, and then my cheese, and then my frozen. So that I have like the legend in the order of like where the lines are on my plot. So it's not that you have to have annotations, but like to think about ways that your legend could even be more clear than it currently is.
And then another example of doing this, we kind of touched on it earlier, is that we have our values on the left-hand side, but what if we can just eliminate that and put the values like on the bars itself? I think this way it makes it a lot more clear. We can see that for Brazil, it's 209 million people, and then for Italy, it's 60 million people, as opposed to coming here and seeing, oh, I don't know, it looks like it's about 60. I think it makes it a lot more clear when you specifically say that. But if you wanted to keep like the grid lines in the background and have it, that's fine too. But these are just ways where you can like, I don't know, implement some of these practices in a sense.
Yeah, it's kind of like what you were saying about like how those comparisons are really hard. So even if like, let's say even if visually you prefer this orientation to something that's been sort of rotated, like it would still give you an easier way to sort of make the comparison between, oh, 209 and 60. Like even if, I don't know, sometimes for me, I think that it's easier to draw like a line straight down to see where I am on an axis than it is to draw over. Maybe I'm just like kind of bad at drawing straight lines. But like without, like when you don't, like Lana saying, when you don't have to go all the way across and like sort of move your head from side to side, and you have these sort of things where people can make those comparisons, it's way more clear.
Next, we're going to talk about colors. So for qualitative data, you can see right here, we have a categorical variable representing 3 different, like, I guess that thing, like races, yeah. And then you can see that each color is distinct like from the other, so it makes it clear that these 3 are different. And like we said, it's ideal for categorical variables. And then for sequential variables, so right here, we're looking at percentages. It could be something like dollars or yeah, anything that's quantitative, we can communicate with sequential or we can communicate with like a gradient. So we can see here that this is like the same like color-ish, but we're moving from a light yellow all the way to a darker like orange, brownish color. And it makes it clear that like this is obviously the least percentage, and then this would be like the highest percentage, as opposed to maybe using like different colors to represent that value. And then for a diverging data type, so positive or negative, or let's say hot and cold, where two things are like are opposites of each other, we want to use two different colors with a neutral color in the center. So like, for example, another example would be like, oh, blue and red for Democrat Republicans, right? They're two different things. So it just makes it clear which state is like green, and then we can see this is like the opposite, and then the more neutral colors have like a more neutral change. And we want to talk a little bit more about color blindness. So a way that we can kind of be more mindful of people who, I guess, can't really tell the difference between colors, we can use like patterns to like, I guess, differentiate between the different variables. So in the case of this categorical variable, we're using different patterns here. And then for a quantitative variable, we're using different shapes to represent the different categories.
So this is like in statistics, this is called double encoding,
Mhm.
where you are mapping, like where you have two things associated with essentially one variable. Like you have one categorical variable here, you have like west, northeast, and south. And south has essentially two things like double encoded with it. One is that the color is like pinkish. And the second one is that it has a sort of checkerboard pattern. So it's a double encoded sort of variable where we are able to say, like, even if somebody can't necessarily differentiate between these different hues, then they can differentiate between these stripes, these dots, and this sort of checkerboard. And like that's a good way to sort of be able to. There's also I think in a variety of different languages, like however you're making your pots, there are resources for like ways that you can have sort of color deficiency friendly color palettes. And yeah, I think some of my favorites, like if you are picking out colors, there I use a color picker app, which is I think I just Google like color picker, and it actually is an app that you can upload a picture that you like the colors of. Like I recently uploaded a picture of like all the poppies because I wanted like a poppy color in some of my plots, or different wildflower colors. But you also can upload, like if you find a web page that you like the colors on their web page, like you can copy and paste the address, and it kind of takes a picture of that website, and then you can use essentially your cursor to pick out like what color it is, and it gives you either the RBG sort of numbers for like what that color is, or the hexadecimal representation, like a way for you to get that color infused in one of your plots. But I use that a lot because I see people's colors in their things. I'm like, oh, I want to use that. So it's a way that you can kind of get the colors of things that you like, that you see out in the wild.
Thank you for the resource. Now we're going to talk about backgrounds and grid lines. So looking at this plot, anything that you notice?
What stands out?
Yeah, what stands out?
Show through the colored data areas.
All right.
Yeah, like the grid, you can't, you can either see the grid or the colors. But the grid is super dark, like it's really hard. Like it seems like the grid is almost as present as the color. And you don't necessarily, like, if the plot's intention was to communicate what's going on with the colors, then like it's kind of taking a back seat compared to the grid. Like it seems like both of them are equally sort of like vying for like their importance in the plot. And I don't think we want our grid lines to be the most important thing in our plot. We want it to be the data that we're using in our plot to be the most important.
So here are two better examples on how to represent this. Our grid lines are a lot less present in the graph, or we can just take them out if we don't want them. But you can see between the two graphs, here, like Dr. Theobald was saying, like the grid lines and what we're trying to communicate are both very present, and we want to, I guess, not have it be so present in the graph. It's very striking to look at, as compared to these better alternatives.
Yeah, grid lines should, well, like I am a fan of having grid lines. I think that they're kind of like visually they're anchoring points. So I would have a hard time having no grid lines in one of my plots. That's maybe just who I am. But like what the first plot was is that it had both major and minor grid lines, and that's like the same thing as the plot that we like showed you initially that had the gray sort of background, and it had all of those lines, like all of those cross sections that you can think of. Like major grid lines are the grid lines that have numbers associated with them. Those are sort of the major, where the labels are. The minor grid lines are like the places in between. So if you like, the general recommendation is that you eliminate minor grid lines from your plot, and you only have grid lines where you essentially have labels. That reduces the clutter and makes your plot a little bit more clear. But even notice here that like compared to the first one, those grid lines were super dark black. Like it was really like they were really present because it was a very saturated sort of color. And once in this one, like they're still here, we still have those major grid lines, and technically were only major grid lines before, but that color is now sort of softened. So it's a lot easier, and you could even like make it even a softer gray. You could make it dashed lines and like a very light sort of ivory sort of color or something like that, just so that like they're not like sort of reducing the visual presence so that your data can sort of speak for themselves.
Hey, is it possible to slow down a little bit?
Here's another example. Like we said earlier, like these would be considered like the major ones. Like we don't need so many like intervals. We don't need 10, 30, 50%. So I guess when you take away like the amount of intervals, the amount of grid lines, you can kind of see it's just a lot more clear, and it's a lot like cleaner to look at. And then here's another example of not having a legend and just putting the values straight onto the graph as well.
And not having a y-axis label.
Yes,
Because
that
like,
too.
because we're like, well, what are these percentages on this side? Well, they're described in the title. It says success rates for top features continue to improve. And so we know that they are success rates. And now we know that the context that they're success rate for top features. And I suppose that like their title is even making a claim that they're saying like these are even continuing to prove because we're seeing over time that these are increasing. So you could possibly even make a claim about the relationship that you see in your data in your plot title, like making it work for you so that people are sort of getting all of that information without even reading your paper or something like that. They should be reading your paper, but also like people's eyes are naturally drawn to images. And so it's possible that they will read that first before they read your results or something like that.
Again, this has a lot of grid lines when we can just put the labels straight onto it. It just makes it a little more clear. But I guess like there's different preferences. So like Dr. Theobald, maybe she would want like a few. Just because maybe depends on the context. So yeah, it's just good to keep in mind what you like can or can't do or shouldn't do, I should say.
I'd say I'm a little less like picky about grid lines in terms of like categorical bars. Cause like when you're thinking about like anchoring points, like the anchoring is sort of like where, like how you're visually comparing what like that value to. But here, like we're actually just superimposing like what that value is. Like that's not something we necessarily want to do with a line plot where you have like literally every single number all along your line. Like that would be total bad. But like, so that one, it makes it easier to see like along that sort of line as it goes, like where are you sort of in that like quantitative space. But here, I don't necessarily need to know like where this bar is in quantitative space if I put a label on it. Then all of that sort of like getting used to where it is in space like doesn't even have to happen. No.
All right, thank you so much.
We managed to get through that all. Yeah. And we still have like 8 minutes. So what questions do you all have?
What is the recommendation for like the best like software application or like
I'd say the software that you're the most comfortable with. Yeah. Because like if you're trying to make all these changes in something that's also new to you, like that just like compounds. So you notice like some of the plots that we included were from Excel. Some of them, the initial ones I made in R because that's just what I'm the most comfortable with. I honestly like Lana and I were talking, like I honestly don't necessarily know like how I would make those plots in Excel. So like I could have gone through the effort to make those, but like I don't know how. And so if I wanted to really like tell a story with my data, the easiest way for you to tell that story is for something that you're familiar with. So if you're familiar with Excel, great. If you're familiar with Python, great. If you're familiar with R, do whatever tool. Like I think that there are differences in like how the results you get between your different tools. Like you're not going to get exactly the same plot, but like you can apply the principles in very similar ways.
Any questions from the Zoom chat? Dr. Lear, was your hand up?
Oh.
Yeah, I wanted to thank you all so much.
Yeah, I recorded it, so I will get that over to you.
That's great. Thank you. Yay.
Oh, we can't hear. Dr. Lear, we can't hear you. I think you're muted. Okay.
Dr. Lear, can you say that again? Oh, thank you.
Yeah.
Any other questions?
I would like to plug, if you don't have any other questions. So like as you're doing research, and you're making your plots, the statistics department does have a statistical consulting service. There are, I think currently this quarter, there are 2 consultants available. I don't necessarily know like how many projects they're sort of juggling right now, but like if you want to sit with somebody and ask them a few questions about your plot or like how you can make it better or any sort of stuff with that. I know one of them like does sort of specialize in statistical communication and that's like what they're interested in. So it wouldn't hurt to reach out and see if they have any sort of time to sit down, like even for a short meeting and make some suggestions for you. I can give you their names and emails if you're interested in that, but I think it's also possibly listed on the staff department page. But that's a resource that's available across campus, not just for undergrad research, but I want you to know about it because I think a lot of graduate students use it, but I don't know how many undergrad students use it.
Thank you.
All right, thanks for having me. Good job, Lana. I made all the presentations. It was so great. And inspired to make it all on